exercise number 5 that says get combinations, choose out of 6, 5. So you could just do this without any calculator because we have 6 pieces. So you could choose either first one, or you could choose second one, or third, or fourth, or fifth, or sixth. So there are actually 6 choices. As Alex, you're selecting one. Yes, I select one that I don't touch, and the other 5 will be actually the chosen ones, right? So you select one that you don't touch and 5 what you select. And the other way of doing this problem was a calculator way that you could also utilize. And for that, I need to find a scientific calculator. Scientific calculator. The one that we always use in class, that's a free calculator. So you just type scientific calculator. And the first choice called Desmos is available for free. So we go to functions, we go number of combinations, then return back to main, and you go 6, comma 5. That's how we get this combinations entered. And you can see that combinations choose 5 out of 6 is equal to 6. So just a use of calculator. So any way you do this gives you the same answer. So I asked on the quizzes to just produce the answer. It looks like pretty much everyone did it right. That's great. Now, if you did not do it right, well, you can always fix that by doing extra credit exercise from any section you like. So extra credit exercise is a even problem. So you can select even problem in this section or anywhere that you prefer. So exercise 3, let's do that. It says, how about 4-letter words that we form out of these 1, 2, 3, 4, 5, 6, 7 letters. So it looks like from exercise 3 from 7 letters, I will be producing 4-letter words. Now the question is combinations or permutations. Well, when you're producing passwords, would it matter if you put password A, B, C, D, or if you switched A and B? So if you get B and A, that'd be different password. Well, you can try if you have your password, if you switch a couple of letters, it's definitely not going to work, right? So order is important. We have permutations. So from 7, we choose 4 and get calculated. So I just put this again in the calculator. But now I need permutations, of course. So I go to functions, permutations. So the key point is always to decide if you care about order or not. And of course, when you produce this permutations, you do care about order. So we have the answer, 840. So this section does not really have much in it, but it's a good continuation of a previous section with permutations, where we talked about having order, and now we're talking about whether we have order or not. So it's one step farther. And in the next section, we'll continue with this story, of course. So let me bring you to the next section that actually talks about probability. Probability that deals with dividing two things one by the other. So what they have here in next section is a definition how we find probability of any so-called event, and we divide total number of possibilities into number of possibilities that you're interested in. So what does that mean? Well, I guess the best way is to take a look at the particular exercises. And here's a nice picture, figure 11.4. So I can use it to give you a few examples of probability calculations. So it looks like total number of possibilities if you just roll a little cube, they call it as a die. So if you roll this die, then you get 6, right? You can get on the top of it either 1 dot or 2 dots or 3 dots. So they're looking at the top, not on the side, right? So whatever's on the top, that's your outcome. So either 4 or 5 or 6. And that's what they actually put here with a set they call a so-called sample space. That's a statistical word, sample. So all the possibilities are here, and there are 6 of those. So what if somebody wants to find probability that they roll 6? Let's say I'm very lucky. I always get 6 whenever I play game. I get 6 whenever roll this little cube. So to find probability, I need to put the total number of possible outcomes, those total number of possibilities in denominator. So that was 6. And it looks like what we're concerned with right now is just the one that has 6 in it. And out of these possibilities, there is only one that I care about. So 1 out of 6. So that's the probability. So word probability stands for a fraction that has denominator with a total number of possible outcomes. And in numerator, we have number of choices that we're interested in. So in this case, we had just 1. Well, let's get another one like that. So for example, what's the chance that you're gonna roll this same exact die and get 1 only on it out of 6 choices? How many ones do we see here? Say I see only 1 of them, right? Only 1, which is right here. That gives me 1. So it looks like it's also 1 out of 6 probability. And it's the same as if you find probability to get 6. So 1 out of 6 looks like will be a probability to get any of these outcomes when you roll your die. How about if you try to get even number on a die? How many even numbers will be here among these 6 outcomes? Please notice when I find probability, I'm always going to put 6 in my denominator of the fraction. And it looks like I see 3, right? 3 out of the 6 that give us even result. It's 2, 4, or 6. So I can simplify it and say it's equal to 1/2. 1/2. So by looking at this answers, I can come up with first formula for the probabilities. There is a special law that we want to consider. And this law says that probability of any event E, as they like to call it here, is always in between 0 and 1. And it may be equal to 0 and it may be equal to 1. What does that mean? Well, if you get this fractions calculated by calculator, you're going to see that they're equal to 0.5, or 1/6 will be equal to something like 1677. So they're always going to be less than 1 or less than 100%. It could be a 0. For example, if you say, how about probability to get 7? I want to roll this die and get a 7. How many possibilities out of these 6 are 7s? When you say, Alex, I'm looking at this 6 outcomes and I see no 7, so it's going to be 0 out of 6. So chance to get 7 will be equal to 0, which means there is no chance, 0 chance, so you're never going to get 7, no matter how many times you roll this little cube. So 0 is the lowest possible probability. The largest probability could be 1. For example, if you say, what's the probability that I get something when I roll it? So if I get, people say, at least 1. If I get 1 or more out of these 6, you will say all of them are going to be at least 1. 1 is fine, 2 will be even more than 1, but that fits description. It's at least 1, maybe more, 5, or all of them. So all 6. So it looks like the probability of that will be the largest, will be equal to 1 or 100%. So when we are dealing with probabilities, the largest probability we get is 100%, which is 1. And 100% means this event is going to happen for sure. So no matter what, this will happen. So you don't need any higher probability than 100%. I know some people, to show their confidence, say, I'm 200% sure or more. Well, you don't do this in probability because the largest possible is 1. And that's the actual law for the probability. Of course, 200 or 500% possible in other math examples, when you, for example, major double profit, so that's 200% of the profit. So those things are possible, of course, but not in probability. And that's important to realize. So when you be doing exercises, and if you happen to produce the answer, which is more than 1, well, it means that something is not done correctly. So you better double check your calculation, because 1 is the largest. And of course, you cannot produce negative probabilities, because negatives are also not possible. So that's important to realize. And they're talking about various examples in here with either those little cards, playing cards. They made a nice picture here. You can look at this. So we can look at the example. Probability is calculated when you are having a deck of playing cards. And of course, it's important to know what is in this deck. And when I'm looking at all of the cards here, they say these cards range from 2 to, they range from 2 through 10. So ace is also added, so we get 10 cards. And also 3 so-called face cards, Jack, Queen, and King. So there will be 13 cards in each of 4 suits. There are 4 suits here. You can see there are hearts, clubs, diamonds, and spades. So there are 4 suits, 2 red ones and 2 black ones. And each of these suits has 13 cards if you have a fair deck of cards. So 13 times 4 gives you a total 52 cards. Let's say there are also jokers. Well, when they play games such as a poker game, they don't use those jokers, so they just have 52 card deck. And it looks like that's what they're talking about here in the example. So they're wondering, what's the probability to get a king when you have a deck of 52 playing cards? So out of this 52 cards, so I put 52 in denominator, how many kings do you see here? And turns out there are 4 kings. In each suit, there is only 1 king, so you can see those kings up here. So it's a king of hearts, of clubs, of diamonds, and king of spades. So 4 out of 52. Please notice we never leave answers in a form that we can simplify. So you could just reduce this by 4, or you could just take your calculator and get a decimal. That's probably even more convenient. So how about if we look at the probability to pull a heart from a deck of cards in a part B? So to get a heart, looks like there are 13 cards of this suit, right? And total is still 52 cards. So it'll be like a quarter chance that you pull out a heart, right? Well, one can say it's 1 out of 4 suits, so it's 1/4 ended. So how about part C here that says king of hearts? How many kings of hearts in this deck of playing cards? And it looks like there should be only 1, right? Only 1 such a card out of 52. So we get all kinds of fractions. And that's the point of story of this section, that we now going to be producing fractions. We always divide total into the number of possibilities that correspond to your question. So if they want a question with hearts, well, how many hearts? You put that in numerator. So we can do some exercises here at the end of section as usual. So let me get there. So we can just start with this first page, exercise 11.4, and next time I will, of course, continue talking about this section. So just to start. So how about if we get exercise like number 7 to start. 7 that says, if you have a likely outcomes for the little cube that you roll once, so looks like in exercise 7, you need to have a probability that your result is less than 20. Let me see, what kind of question is that? We roll a little cube 1 time, right? So there are 6 possible outcomes. We just saw it in the beginning of this section. And looks like they're all 6 less than 20, right? And 1, so I underline those possibilities, and 2 and 3 and so forth. So they're all less than 20. So all 6 fit description. So the probability is equal to 1. So one needs not to panic. 1 is possible. Why not? So the point of story, they can ask you any kind of question. And what we need is just to answer it at our best abilities. So let's try one more. How about in the next group of exercise that deals with 52 playing cards, what's the probability to get a picture card. Picture card or face card. So out of 52, how many will be faces? And looks like they talking here about either jack or queen or king, right? Those are picture cards. So 3 of them times 4, because there are 4 suits. So it's really 12 out of 52. Let's say, so I have to reduce this. I have to divide this by 4 or something. Well, you don't have to worry much about the arithmetic. You could just put this in a calculator and get the answer without bothering simplifying it. So you could just write this as what? 0.2307. So put few of these digits. Dot, dot, dot. So it's about 23% of cards have pictures on them. So that's how this deck is designed. So we get some type of a decimal for the answer, because we usually have to reduce this. And notice if you start to reduce, you're gonna get divide by 4 your numerator, so it will be 3, right? And if you divide by 4 your denominator, that will be 13. So another way to get this is 3/13. So if you like fractions, then you can write the answer as a fraction. Or if you don't like fractions, I know lots of people say, no, Alex, I don't like fractions. So you can just put this in a calculator right away and get the answer, and that'd be it. So how about if you try for a little quiz for today, exercise number 11 with this cards. And exercise number 11, they say, what about probability to get a queen? How many queens are there in a deck of playing cards? So quiz for today will be exercise 11. So please tell me what be the probability, but again, make sure that you reduce it, right? It should be always simplified. Either put it in the calculator, get decimal, or you can write it as a fraction in the lowest terms.